Welcome back. This lesson covers file handling and exceptions as part of the Python Advanced series. We're going to focus on how to handle text files and how we can open them, append them, read from them, close them, write to them. Then we're going to look at how to take data and split data from a text file and maybe put them in arrays, and how to do exception handling where we deal with those pesky errors that might occur. So we preempt errors through exception handling. This lesson is part of the 9-lesson series which deals with Python programming for paper 4. So let's begin. What is the purpose of a file and why do we need to use them? Well, if you know your basics of computer science, you know that most of the time data is in RAM and RAM is volatile. So when user data is manipulated and the power is on, data stays in memory. But when we turn the computer off, that data is lost. So to store data permanently, we need to store it in a file. It also allows data to be transferred from one application to the other, and it also allows data to be loaded into memory on a future date. So say, for example, you're playing a game and you wanted to save your progress, you will need to save it in a file, and then when you reload the game in the future, your progress is loaded into memory. There are 4 modes that we can access files in, and those are read, write, append, and random. Read mode is used when you want to read data from an existing file. The file already exists, so you're going to open it up and read data from it. Write mode is used when you want to write data to a new file. The file doesn't exist before and you want to create this file. Now if you use write mode on an existing file, it will overwrite that existing file and write something new to it completely. Append mode is used when you want to write data to an existing file. It adds data to the end of the file. So the difference between write and append mode is write will overwrite everything or create a new file. Append will add to an existing file. The random mode is used when you want to work with binary files, and binary files are files which store audio or video. The first 3 modes are used when we work with text files. We don't need to know how to program random files, but you need to be aware how random files actually work. In the paper 4 exam, you're going to be given text files to work with. Random files, you only need to know the knowledge of, and that's for paper 3 and pseudocode format. So how do we go about reading data from a file? Well, step 1 is to open the file, especially in read mode, and you use the open function. So in Python, we use file equals open brackets file name in strings, comma, R in quotes. And this R stands for read mode. So it's pretty simple. So open whatever file name .txt, comma, in read mode. Step 2 is reading the content of the complete file. Again, by using the read function, you can say this variable is equal to file.read brackets. And this built-in function will just simply read whatever's in the file into this text variable. And then we close the file, because if you don't close a file that you've just opened, it could lead to errors or security risks in the future, because the file is already open and someone else or another program can access it. So you've got to close the file, and there's normally a mark given for closing the file every time you open it. And if you miss that, that's the most easiest mark to lose. Okay, let's look at some code on reading data from a file in Python. Well, first you've got to have a file, which in this case is called highscore.txt. Why do you need this file? Because if you don't have a file, you can't open it up for reading mode. So this file needs to be written and stored somewhere, normally in the same directory as your Python program. So what we're going to do is we're simply going to assign a variable called file, and we're going to open highscore.txt in read mode. Then in a variable called text, we're going to read the entire file and store it in there, and then we're going to print text out. That's all there is to reading from a file. Of course, you need to add file.close at the end, otherwise this would be incomplete. So make sure that you put that in at the end of this code. But sometimes we might not want to read the entire text file. We might want to read it a line at a time. And in that case, Python has a built-in function which is called readline. And this function is used to read a single line of text from a file. Now, this function is commonly used in situations where you want to read line by line rather than reading the entire document at once or the entire file at once. So how does it work? You open your file as normal. So file is equal to open highscore.txt in read mode. The first line is going to be file.readline. The second line is going to be file.readline. So you run the command twice. And most of the time, if you know the number of lines in your text files, you can just do a loop here and it will loop through the entire thing. But here we're just going to look at 2 lines. And once we've loaded 2 lines up, we can print them out, print first line, print second line, and then close the file. That's how simple it is. So do test this out, do code it before continuing so you get familiar with handling text files. Because it's time for practice question 1. Now before you begin practice question 1, you have to manually create a text file with data for 10 players and their scores for a game. The first line should have the name of the player and the second line should have their score. So Remy 34, Clavel 45, and so on. Save this file as highscore.txt, and when you have this file, then you start writing the code. So the task is to print the complete file by using the readline function. So pause the video, have a go, and then continue to see a possible answer. Hopefully you got something like this. You've opened the high score text in read mode and into a variable called file, and then for x in range 20, because there should be 10 players and 10 scores, text is equal to file.readline, and then you print text out and then you close the file. If you went the long way and then said line 1 is equal to this, line 2 is equal to this, and then something like that, you've done it the inefficient way, and that will take too much time in an exam. So get used to using loops with files to speed up the process of reading and writing to them. Okay, practice question 2. Find the sum of scores or numbers from the previous file. So build on your code and see if you can output the sum of the scores for that file. Hopefully you got something like this. You've got a variable called sum which is initialized to 0. You open your file. Then for x in range 10, why 10 this time? Because we're going to load 2 lines separately. So text is going to be the first line, score is going to be the second line because that contains the score value. And then we're simply going to say sum is equal to sum plus the integer of score. So we convert that text, because it's in text format, string, into integer and add it to sum. And we loop it 10 times. That's basically 20 lines in total. And then we just add the second line to the sum. We close the file at the end and then we print the sum out. So hopefully you've got something like this. If you haven't, pause the video, code this, and then continue. Now we're going to look at a couple of special functions which are used to break things apart within a line. Now we know that the text file is an entire string of text. We can break it into line by line using the readline function. But what if within one line there are multiple text values like comma separated values and so forth? How do we deal with those? So the first function we're going to look at is the strip function. This is a string method that removes leading and trailing whitespace characters from a string. Whitespace characters include spaces, tabs, and other new line characters. So an example is the text is hello world. It's got a space at the beginning and a space at the end, and we want to remove that and just keep hello world. So we're going to create a variable called stripped underscore text, and we're simply going to say text.strip, and then we're going to print the stripped underscore text out. That's going to strip any leading and trailing spaces and just have the entire text in there. Now this is very useful when you are in a text file and then each line is separated by an enter, which is called a new line character, and then you want to make sure that you strip that part out. Now the second part of this is called a split function, and both of these can be used in combination. So strip brackets dot split brackets. Both of these can work together. But we're going to look at this one individually first. Split function is used to remove any extra whitespace characters which are part of a string. For example, you might have comma separated values on one line. You strip that line out and now you're going to split each value that is separated by that comma. So an example in this case is text is equal to apple, comma, banana, comma, orange, 3 values combined together as one string. We're going to say fruit is equal to text dot split brackets. The character that we want to split by is comma, and then we're going to print fruits out. The output is going to be apple separately, comma, banana separately, comma, orange separately. So we split that string into 3 parts. Now this is quite useful in Python because often text files will have multiple lines separated by commas, and we can use both of these functions together to break individual parts out and utilize them, especially to load them into array indexes and so on. So let's have a go at practice question 3, which puts all of this together: your readline, your strip, and your split functions. Create an array with 10 elements in which you will store all the player name and scores. Array name should be called file data. Open the file and store all the player names with their score in the 2D array. The function you should be using here is a combination of all 3, and you can use it in this way. Text is equal to file.readline brackets dot strip brackets dot split, and in that bracket you put a comma in because we're going to have comma separated values in our file. Now you need to set the file up like the two lines at the top right hand corner of the screen. The player names are all going to be in one line separated by commas, and on the second line you're going to have all the scores separated by commas rather than spaces earlier. So set the file up, pause the video, have a go, and then continue to check a possible solution. Hopefully you got something like this. You've set up your file data 2D array, you open the file in read mode, then in line 1 you read the line, you strip it, you split it using the comma, and in line 2 you do the same thing with the second line, and then you create a loop which runs 10 times because there are 10 items, and then you update each column of the array by putting the name and the appropriate score right next to it. And once you're done, you print the file data out and close the file, and that's it. Run this code and you'll probably see that each player will have their score right next to them in the array. So on to practice question 4. You're going to create a procedure output high scores which output all the values in the data structure in the format player name score. For example, the first two data items are going to be like this: A1, B2, and so forth, or in this case FYI 10,000, ABC 9092. Write program code to declare the procedure output high scores. Pause the video, have a go, and then continue. You should have created an output high score function which loops 10 times, and then it has a variable, in this case I called it combine, which takes the index column 0 plus a space plus index column 1, combines it together, and then we print it out. So each combination is printed one by one. And when you run this function, you should see A1, B2, C3 printed out in rows. Okay, that's enough about reading. How about writing to a new file? So say if you wanted to create a file or you wanted to overwrite an existing file, how does that work? Well, step one is to open the file in write mode using the open function. So exactly how we did read, file is going to be open filename.txt in W mode, which is write mode. Step two is we're going to write whatever we want to write. So file.write whatever string, whatever variable in the brackets, that's going to be written to the file. And step 3, we close the file so nobody else or another process can't access it. That's all there is to writing a file. Here's an example on screen. We're opening new file.txt in write mode. We're writing, computer science is the best to it. We're closing the file. Then we're opening the file in read mode. And then we're storing whatever's in the file in a text variable. And then we're printing this variable out. And then we're closing the file once again. Now this allows you to check what you've written is in the file. So you should have an output on screen which says computer science is the best. And you should also have a new file.txt created in the same directory as your Python program. Okay, time for you to practice. Practice question 5. Create a new file with the name event_guest.txt. Take input from the user, the names of the guests they want to invite in the event. When they type no, stop taking input. The name should be stored in the file. Each name should be on a new line, so concatenate /n in the name when you write to the file. This means that whenever you're writing, /n means you will move it down to the next line for the next input and not on the same line. Otherwise, you're going to end up as one joined up string. Pause the video and have a go. Hopefully you got something like this. You've opened the event guest.txt in write mode. Here I'm just setting a flag true because that's going to run my conditional while loop. I'm going to get the user to do an input. This input will continue until the user says no. So if name equals no, the flag is set to false and we exit the loop. Else we write name plus /n, which is a string, to concatenate that with whatever the user's input, and that's written to the file. Outside the loop, we're going to close the file so no one else has access to it. So that's basically what the code is. Hopefully you got something similar to this. If you haven't, pause the video, study it, code it, test it, and then continue. So what if we want to write to an existing file? We don't want to overwrite it. We want to append it. The process is exactly the same. This time we're going to open the file in append mode. So you just put a at the end of it. So file is equal to open filename.txt, whatever it is, comma a. And the a stands for append. We're then going to write whatever we want to write using file.write. And that's going to be stored at the end of the file in the very last line. Once we've done that, we then close the file as normal. So that's pretty straightforward. All you need to do is the same line of code, and you just change the mode by writing R, W, or A, depending on what you want to do. So let's look at an example. Here we open the file in append mode. We write computer science is still the best /n, and then we close the file. We open the new file in read mode. We print the file out and we close the file at the end. Now this should output computer science is the best, which was the original line, and then another line which says computer science is still the best. So it appends to the existing file rather than overwriting it. Time for you to practice using practice question 6. Append your name in the file event_guest.txt. Make sure it appears on a new line in the file. Pause the video, have a go, and then continue. Okay, let's look at the solution. Here we're just inputting a name. We're opening the file in append mode. We're writing the name variable plus /n to the file, and then we're closing it. Now I don't have to get an input. You could just write the name instead of the name variable as a string. But I wanted to show you that you could also write variables to it rather than just strings. But what if the file has an unknown number of lines? At the moment, we've just been dealing with files which are 10 or 20 lines. What if there were hundreds and we don't know how many there were? In this case, you would open the file as normal in read mode, but you're simply going to use a loop which says for line in file. As long as there is a line in the file, keep doing this. So that bit of short code allows you to automatically access each line in the file until you reach the end of the file. So that's in effect an EOF command, an end of file command. So let's try practice question 7. Append your name or an alternative in the file event_guest.txt, but first check if the name is in the list or not. If it's in the list, then print already invited, and if it's not, then add it to the file. So you've got to use a loop, a selection, perhaps a flag here as well. Pause the video, code this, and then continue to check a possible solution. So here we're opening the file event_guest.txt in read mode. We're setting found to false because it's changed to true if we find the name in our file. If not, we will just use it accordingly to print a statement. So for line in file, if line.split equals whatever the name is, found is set to true, and we print already invited. We close the file. Brilliant, that's done. However, if going through the entire file we don't find the name, found is still false, then we open the file, but this time in append mode, and we write the name plus /n to the file, and then we close it. Okay, that's all there is to file handling. We're now going to move on to exceptions. So what are exceptions? An exception is an unexpected event that disrupts the program. For example, reaching the end of the file before you expect it to. Exception handling is the process of responding to an exception within the program so it does not halt or stop unexpectedly. Now examples are dividing by zero, reaching the end of a file unexpectedly when you're reading data, trying to open a file that does not exist, or losing connection to a device. For example, somebody pulls a USB out of your computer while you're writing to it. Now, of course, these type of errors or exceptions can lead to crashes. So how do we handle them? A good programmer will think ahead and try to anticipate the challenges that might occur in the real world. So we use exception handling, which is in the following format. Try, which means try this code, and when you encounter an exception, do this. It's kind of like an if-then statement in a way, isn't it? So try the main code, and if you encounter an exception, like an input-output error or a file handling error, then you output this method or try this code. That's all there is to exception handling. 2 commands, try and accept. And this is normally about 2 marks in the exam. So make sure you know how to utilize these. And these are hidden marks at times when you're dealing with files. So when you have a file handling task in the exam, always use exception handling. So how does it look like? Here we've got a division function which takes in 2 numbers. We're going to try this code which says answer is equal to number 1 div number 2, and we're going to print the answer out, except if they put number 2 as 0, we're going to output the statement print you have divided by 0. So this will write this message on screen rather than a crash. So when we do division 12,3, this should give us 4. When we do division 10,0, this should give you the error message. That's how exception handling works. Try this code and see it in action. How does exception handling work with files? Well, it's pretty much the same way. In this case, we've got a function read file. We've got a global data array where we want to store whatever's in the file. We're going to try this code first. File, open the file in read mode. For I in range 100, we're expecting 100 lines. Data array I is going to be the integer version of whatever's on each line. And we're going to have an exception, which is called an IO error. Now we can give it names. In this case, exceptions can be linked to built-in ones like value errors or input-output errors, which is IO error. And then we simply say file could not be found. So for example, if the integer data.txt file didn't exist in the same directory as the program, it can lead to a crash. Here, we're just going to output the message, the file could not be found, instead of giving a crash to the user. So that makes it a bit more user-friendly. And that's all there is to exception handling. Two keywords, the main code is part of try, and the error message is part of except. Hopefully you've understood the purpose of a file in programming, and you've also understood the 4 different modes a file could be handled in. For text files, we only deal with read, write, and append. We don't use random in paper 4 because they will not give you a multimedia file, only text files. So we don't need to learn how to code that. But if you are interested in that, obviously research online and learn how to manipulate binary files as well. You should be able to use the read, readline, strip, and split functions, and you should be able to use Python to read and write data to a file in different modes. You should understand the issues with EOF. For example, when you reach the end of a file, unexpectedly that can lead to a crash, and how Python implements it using the for line in file approach. You should understand what exceptions are and how these can lead to crashes, and you should know how to handle them using the try and except method in Python. That's all there is for today. If you've got any questions, use the comments, and I'll see you in the next one, which is going to be our final lesson of the Python programming series.